All right.
We can edit afterwards.
Cool. First seminar of this term. It's a great pleasure to have David here, the author of Attack of the 50-Foot Blockchain, which not only has a great title, but it's a great book. And essentially, what I want you to take away from this talk, besides all the wisdom that he's going to give to you, is buy the book. If you don't want to buy the book, I make sure some copies are ordered for the library, so you can also check it out from the library. Thank you, David.
Hello. Thanks to Martin for organising this. So today's talk is why magic doesn't happen from saying we're putting a blockchain on it. So basically what they're doing is selling a tree of hashes as a vast technological revolution that will change the whole world. So it turns out that's a bit overblown. I'll have to zip through this. So I started as a music journalist. That's why I started writing and publishing things. I moved to IT because it pays about 3 times as much. I've been a Unix sysadmin for the last 20 years, so basically what I do is I see exciting new technologies, work out why they're terrible, and then make them work anyway. I started following Bitcoin in 2011 because I'd heard about this thing where you could get rich for no effort. And so whenever anyone says there's a get-rich-quick scheme, they're always wrong. There is no get-rich-quick scheme. So the first thing you have to do is work out what's wrong with this thing. Turns out there's quite a lot wrong with Bitcoin and everything about it. So it's one of those fascinatingly bad things that I followed for a few years. I started writing a book late 2016. Nobody cared about Bitcoin then. Then the second crypto bubble started and the book came out just in time. So that was well timed. So every time I do a talk, people ask, what is a blockchain? They always assume everyone else knows. This is a computer science audience, so you'll probably have some idea, so I'll zip through this. Okay, let's say we have an accounting ledger. So you have just a list of transactions, money going from people to other people, a date, an amount. We want to make copies of this. How do we make sure the copies are correct? We do the obvious thing. We put a hash on it. Now, a hash, of course, is a function. You take any data, you run it through the hash, you get a number. It should be cryptographically secure, so it's like completely evenly distributed. That means it's easy to turn data into a hash, it's very fast, but if you have a given hash, it's almost impossible to reverse, almost impossible to fake. So if you have 2 chunks of data that have the same hash, they're pretty certainly the same data. So now we know each of our entries is correct, so that's good. But what if we have thousands of entries? And also, how do we tell if an entry has been added or an entry has been removed? We do a little trick here, which is we take a hash of the hashes, because that has the same cryptographic guarantee. If we know the last hash for this whole tree, then we know that all the data is the same. And also, if we have 1,000 entries here, we don't have to rehash all the data. We just hash one line, then hash the hashes, and we have a new hash, and we know it's the same data. This is a simple but very powerful trick. So it's impossibly slow to fake. This is called a Merkle tree or a hash tree. It was invented in 1979. It's used wherever it has applications. Wherever you want a ledger, you can only add things to and not remove things from. And where it's really obviously tamper evident. Anyone who's used Git, you'll know this, where the hash of a given revision verifies the whole repository. So it's used in BitTorrent, ZFS, Git, and Bitcoin. Bitcoin does another trick, which is they take each block, they take the hash and put it on as an input to the next block's hash. So you have a chain of blocks, the blockchain. This is what the blockchain actually is. Now, you note there's this curious lack of magical flying unicorn promises that will change the world through what is just a data structure. At this point, you should be going, maybe this isn't all it's cracked up to be. So where did the magical unicorn promises come from? Bitcoin. Who here has encountered Bitcoiners in the wild? A few. Yep. Bitcoin, the idea is not bad. They thought digital cash would be a good idea, because it would be. If I owe you 10 quid, sending it via PayPal or a bank transfer is fiddly, annoying, and may cost money. It's much easier to hand you a £10 note. So what if we could do that electronically? That'd be a nice thing. It'd be obviously useful. It's not a wrong thing to ask for. We could use this ledger for our cash. Who gets to add new entries? Now, the usual answer is we have a bank who manage these things. I mean, digital cash is quite popular these days. Touch cards are literally more popular than cash in the UK now. So the trouble is that Bitcoiners didn't like the bank idea because Bitcoin was not an attempt to build a payment system. It was a political project by very weird people. So they were extremist libertarians, like not just libertarian as a policy position, we say we want a bit less regulation, more freedom for things and so on. They wanted absolutely no government, no regulation. Everyone is an individual sovereign entity trading bitcoins, and they probably have lots of guns and stuff like that. These people are very odd. They also have strange ideas about economics. They wanted no central authority. Well, fine, you don't want everyone looking over your shoulder, that's a normal urge. But they also wanted a completely rigid gold standard. We went off the gold standard because it didn't work anymore. But there's a certain species of pseudoscience which is taking a disproven idea and deciding it's good, and pseudo-economics works the same way. So, yeah, they also decided credit was bad, and that includes banknotes. You should use the actual gold as money. So Bitcoin was a digital substitute for gold. This had interesting consequences. So 21 million Bitcoins total exist. There's new Bitcoins are issued every 10 minutes. Every time someone calculates a new block for the hash tree, they also get some Bitcoins as a reward. They've mingled the two functions. How do you do this with no central authority? You make it a lottery. So it's handed out sort of randomly. So this is what Bitcoin mining actually is. You get the block, you add a random number called the nonce, and you calculate the hash. You notice that's a really small number. If your number is small enough, smaller than the current difficulty, you win the Bitcoins. If you don't, guess again. So we have thousands of computers in the world's biggest distributed supercomputer network doing nothing but guessing numbers to try to get a hash that has a small enough number. You'll see in the press these are called complex calculations. They're not complex. They are really, really simple. They are dumb. And they are just doing a really, really stupid thing to waste electricity to prove their commitment by showing that they will waste more electricity than anyone else. You tell people this, they go, you must have that wrong, that sounds completely stupid. No, it is actually really stupid. So the economics of this ends up in a Red Queen's race. As more miners come on to mine Bitcoins, the difficulty goes up to keep it at 1 every 10 minutes. So when you have more efficient mining hardware, it doesn't make the system use less electricity, it just means they have more resources to throw at the problem. So what you end up with is a whole country's worth of electricity doing nothing but guessing numbers. The actual calculations, you can do them on an iPhone or a Raspberry Pi. The rest is just wasted guessing numbers. So what does this waste of power for the world's most inefficient payment system in history get us? So here are the promises of Bitcoin. It is completely decentralized. There is no central authority. You don't have to trust anyone about the state of the system. Fast and free. Uncensorable. You put anything onto the blockchain, it'll stay there. No one can reverse your transactions or say, aha, you can't do that. And only a limited supply. So how do these work out? So Bitcoin had basically re-centralized by about late 2013, early 2014, because proof of work has economies of scale. The bigger you are, the more efficient you are, the more hashes you can calculate per watt hour. So it re-centralized. So 4 mining pools mine most of the Bitcoins. One company controls 2 of those pools. They have about 50% of the mining. That's Bitmain. They make 80% of the chips. Essentially, they are functionally the central authority in Bitcoin. They don't mess with it because this is their business. but it's still trust that's come back into the system and it's not decentralized. So Bitcoin was fast and free up to about mid-2015 when suddenly it filled and transactions were clogged. Suddenly transactions were slow, unreliable, expensive, because miners would pick transactions according to whichever paid them the most. So it peaked at like $55 or I think $60 in December last year when everyone was trying to get their Bitcoin transactions through. It's gone back down again now. The bubble has passed and people have gone, oh, I'm not going to get rich for free after all. But what else? Uncensorable and irreversible. This is true, which is why there's like illegal pornography on the blockchain that will never be deleted, can never be deleted. But irreversibility turns out not to be what users want. When you create new payment systems, you totally have to have customer service and people running them because people make mistakes. Errors, thefts, fraud happen, and people want someone to call. Bitcoin, there is no customer service. There's no password recovery. All fraud is final. If I pick your pocket from the other side of the world, those are my Bitcoins now. One mistake, you've lost your coins. This happens all the time. Some huge percentage of Bitcoins are lost forever because the keys are probably lost. You can't just print Bitcoins, but it's open source code, and the very first thing people did was go, maybe if I make a copy of it, I can make my own magical internet money. So there's 1,000 altcoins, there's ICO tokens, there's all sorts of things. And the market treats all of these as one thing called cryptos. And I'm sorry, but the word crypto is now finance jargon for this sort of thing. I feel your pain. We, of course, know that crypto really stands for cryptosporidium, which is a gastric infection which is quite appalling, and even chlorine can't clear it up. So Bitcoin, if you could create new gold mines by cut and paste, then Bitcoin would be like gold. So there are other coins, other proof of work coins don't do much better. We have discovered that Ethereum literally cannot scale up to cat pictures. The Ethereum developers saw what happened to Bitcoin. They know that they've got some serious work. They are working on some serious computer science work, but they're literally going to have to do new work. It's been 6 months away for years. So good luck to them, but I'll believe it's a thing when it's a thing. And again, it's all one pool of crypto. So there are other ways, maybe we don't need to use the blockchain with proof of work. Ethereum has a proof of stake initiative. Proof of stake started as whoever has the most coins has the most commitment, therefore they should mine the next block, which is what has gets. There are various tweaks to proof of stake to make it not work like that. And Ethereum is a system with billions of dollars of notional value, so they know they have to get it right the first time. So this work again has been 6 months away forever. There's experimental new things, IOTA, Hashgraph, Avalanche, there's a pile of these things. Usually they're selling tokens. They come up with a chunk of gibberish in computer modern and say, therefore you should buy my tokens if you cannot disprove my fabulous thesis. It's time cube in LaTeX. It's terrible. Basically, none of these have proven themselves yet. If anything did the Bitcoin tricks and promises without having proof of work, it would be huge. So you'll definitely hear about it when it happens. Unless you have an interest in the actual mathematics, I wouldn't bother. But have a look over some of the papers, you might have fun parts. So what else can we do with blockchain? Well, there's a big thing pushing blockchain to business, which is going to be the big focus of the talk. So what do organisations want? Any organisation, by the way. Right? Civilization runs on division of labour. We all do different jobs, and it all adds up to a quite nice environment to live in. So we need bureaucracy to manage that, and we have done for thousands of years. Writing was invented to do trading accounts, that sort of thing. So everyone wants to make their bureaucracy work better, so they can do more with less. And the promise is that blockchains will make this all work wonderfully. So the history of this was that Bitcoin was losing its shine by early 2014. The bubble had just popped. Mt. Gox, there was talk of massive fraud. Someone had stolen all the coins. Bitcoin's most famous for people buying drugs on the Silk Road, darknet markets. And so they tried to market it to businesses as blockchain technology. Or the further euphemism, distributed ledger technology. Now that does not mean technology about ledgers that happen to be distributed. It is a buzzword that is a euphemism for blockchain, which is a euphemism for Bitcoin. It is particularly to sell you a particular package of hype. The hype is literally the Bitcoin promises with the buzzword change from Bitcoin to blockchain or DLT. Some of the DLT providers are specifically repudiating that sort of thing, and they're saying, look, these are just ledgers, they're not blockchains, they do a certain IT type job, and that's fine, you know. They're selling a technology without magical flying unicorns, so good. But there's quite a lot of magical stuff in there. They will routinely claim something is decentralized, fast and free. Like, decentralized against who? They don't specify the threat model. And it's a bit odd when it's literally one company saying this. Like, decentralized against you? No, never. And sometimes you don't really want everything to be irreversible and incorruptible, particularly if it has, say, personal data in it. The GDPR, a wonderful law that all right-thinking technologists think is probably a good idea in the circumstances, requires you to have personal data in a redactable database. But there are still blockchain proposals that put personal data on a blockchain, and they're wrong. And whenever there's a hard bit, they say, well, smart contracts will do that. You'll literally see white papers where they have a bunch of participants here, a bunch of magical results here, and in the middle there's a big square and it says smart contracts. So I'll get to smart contracts, but the usual case for business is permissioned blockchains. Because you know all the participants in business, you know who you're dealing with more or less. Even if you don't like them much, you can probably do business with them. You know, you run as a private chain because you don't want your back office on the internet. You don't use proof of work because why would you waste all that power? So there are various names for these things: permission blockchains, consortium blockchains. The advocates will go through fine delineation of variants, but it's all basically a private database with a particular structure. Wait till the end.
Do you want questions at the end, or?
At the end, please.
Okay.
I'm glad there will be questions. So, even if it's shared, someone runs it and controls access to it. Like they say, oh no, participants, we don't control them, but you control whether they can join or not. We had these organisational structures before blockchain, we'll have them after it. It's just a way of organising things. And obviously this doesn't give the magical blockchain promises. Now, smart contracts. These are very popular in marketing because, you know, it sounds really cool. It's a contract, but it's intelligent. So you know these as computer programs. A smart contract is just a computer program. It triggers on certain things happening on the blockchain. If you've ever done enterprise database stuff, these are called database triggers or stored procedures, where you put the program actually in the database to trigger at particular times. I'm a sysadmin. I can tell you these are a terrible idea. If you work for a company that runs a large database, your DBA will tell you don't do that. You should have programs here, the database here, the programs act on the database. You might use triggers to enforce data integrity, but the trouble is it's really hard to reason about them. It's hard to put them in source code, that sort of thing. So they should always be approached with caution. And smart contracts on blockchains have all the problems of database triggers in practice. Now, the idea of smart contracts was that they would be immutable. The threat model was someone would come along and take my money, but if I have an immutable computer program, they can't. So you have to program like NASA programming spacecraft. It's very hard because is there anyone here who's written a computer program that has no bugs and does so consistently? No? Odd that. So if you were doing smart contracts, you want to do things in a super engineered manner non-Turing complete languages, functional, declarative, mathematically provable, that sort of thing. So Ethereum, the first popular smart contract platform, and Solidity, the most popular smart contract language, ignore all that because Solidity is a JavaScript descendant. It was specifically created to target middling JavaScript programmers who had gotten sick of writing bad Node.js, so they wrote bad Solidity instead. This didn't work out very well. Smart contracts on Ethereum have like 100 bugs per 1,000 lines that are just machine detectable, let alone further bugs, which is a really bad error rate. It is now conventional to make smart contracts editable by their creator. And so decentralization goes out the window, so you end up with programs that are hard to fix instead of impossible. How this works out in practice. The one that made a big splash was the DAO, the Decentralized Autonomous Organization. This was the science fiction dream of a completely automatic corporation without human interference. Now, immune to human interference in info security terms means sitting duck for attackers. If you can't fix the code, then you can't fix bugs. So they had it set up so they could, I think they could fix bugs after 2 weeks and voting, but that was a bit of a long of a lead time. They were warned of the security hole, they went ahead anyway, and someone drained $50 million of ether from it, precisely as they were told. And this was large enough at the time that they rolled back the Ethereum blockchain, the underlying platform, so they threw their market integrity out the window. And this was controversial enough that Ethereum actually split into Ethereum Classic as well. So smart contracts are immutable until the big boys will lose money. Smart contracts are, of course, the magical part of permissioned blockchains. So that means computer program, and the salesman says we'll use a smart contract because it sounds cool. It means computer program. So it's an IT project. There are a few of these around. Where they're approaching them seriously without magical promises, and it takes years and has user acceptance testing and all that sort of enterprisey stuff. Some of them are sensible, fine. Blockchain examples in the real world. Now, of course, just because they make no sense doesn't mean they won't be deployed, because terrible technologies get put out there all the time. I have seen PHP 4 deployed in the real world this decade. It's awful. So the main smart contract use case is ICO tokens, overwhelmingly. Basically, you come up with an excuse why something needs a blockchain, hand wave about token economics, people give you ether, and eventually you don't deliver a project. There's a lot of press releases and pilot programs, the majority of which are marketing from IBM, who are pushing this super hard. Initial coin offerings, here's the template. 1, state a problem. It doesn't have to be a problem. 2, tokens can definitely solve this problem, somehow. 3, there are no other steps. Apparently, tokens will solve energy distribution, journalism, photography, all manner of things, and hopefully sell some tokens, which you might think was the whole point of the exercise. So, what are some examples? The World Food Programme is actually really good. It's their blockchain thing. They have a database of people, refugees, who need support, so they give them money. These are smart people who are just dispossessed of their land, so they just go to a new country, they give them money to support them. And this program's been fabulously successful. It's like cut overheads to 2% of what they were. And this is sold as a huge advance for Ethereum. It's not. The 2% of overheads is because they took disbursement of funds in-house. The Ethereum is a 4-node cluster that they run as the only participant. They're basically using it as a back-end database. I wouldn't say they should rip the system out. I would say it's not an example to emulate. The Walmart IBM supply chain trials have been in the news a lot in the last week or two. Now, this could be a good system. We don't know yet. It hasn't been released. All nodes of the blockchain are on the IBM cloud and are administered by Walmart. Their vendors are required to log in and use them. You could take all the news reporting about this, change the word blockchain to database, and it would be the same. Putting all this data on one place is a good idea. Using a blockchain is entirely to market blockchains. The IBM is doing trials with Maersk, the world's biggest shipping company. These are similar. The vendors who Maersk deal with are openly wondering what on earth the blockchain is supposed to bring to this. I mean, they're using a system because they're told to use this system or else. It's a bit centralized. Votes, with one of those wacky .com type misspelled names, they did a military absentee voting trial. Now they had a use case here, which was US soldiers in remote countries who couldn't get a paper vote back in time. Maybe they can do it electronically. We have cryptography now. So it's like secure web pages don't exist, of course. We have to use a blockchain. They had this system, it collects votes, it logs them onto their private Hyperledger cluster, which is a distributed database run by votes. They also use blockchain to transmit the votes. They printed a paper ballot, which they put in the box. So this system worked for a total of 11 voters. It was a pilot program. Their system doesn't really scale. They tried using this system for the Utah Republican primaries earlier this year in one particular county, and it just didn't work, and they had to go back to paper ballots. The voters were not very pleased. So this is my favorite example, KSI blockchain. You'll see in the Bitcoin press there's stuff about Estonia's blockchain revolution, and this is apparently great news for cryptocurrency. So their software is KSI blockchain, released by a company called GuardTime. It was first released in 2007, and they renamed it KSI blockchain a few years ago entirely for marketing. It's just the Merkle tree ledger at timestamps. As far as I know, it works perfectly well. And they openly admit, yeah, we just named it that for marketing. We'll change the name once blockchain goes out of favour. And I can't even say they're wrong, you know, it worked really well for them. So, in real life, someone says, shall we use a blockchain for this? The answer is always no. You may have a use for the Merkle tree ledger because it's a pretty cool data structure. It's underappreciated. And people market this as blockchain, and I can live with that if it's not magical rubbish. I mean, you may actually need a database with these characteristics. Git actually does most of the good stuff promised by these things. You know, you can have chains of transactions. They're diffs, but you know, they're changes, and they go in a chain. You can have branch chains and everything. It's really cool. But the absolutely key message is you always have to remember, if someone promises you something magical and revolutionary, magic doesn't happen. All right? If there's something new, exciting that would change everything, it's probably wrong. It might be right, but you have to check and make sure, and it has to prove itself. Right, that's me. That is the book. It is readily available. You can get hold of a copy. If you're poor, it's on LibGen. And you definitely have questions. So how are we for time? Oh, I zipped through that quite fast. We've got lots of time for questions, and I'm sure you've got a ton. Raise your hand if you have a question, please. Yes?
Yeah, I agree with your kind of analysis of permission blockchains in the sense that, okay, there's loads of pipe and so on, but I mean, fundamentally they're very different from database. Particularly the threat model is much stronger. Now, whether there's ever a real world use case where that's actually used, I mean, that remains to be seen. But I guess the goal, if you think about both tolerance models, they're designed to protect against Byzantine, right?
I mean,
so that's very different to what any existing database would give.
Well, yeah, I mean, I don't mean just relational database, I mean database in the sense of anywhere you put data in and get it back out. Also, threat models, I mean, it depends who your threat model is against. If it's one company running the thing and being an authoritative administrator of the system.
Sure. I mean, yeah, that's a waste of time. But I mean, at least the promise is that you have multiple potentially mutually interesting entities running this database collaboratively. And an existing database wouldn't protect against the case where some subset of those participants are malicious. Whereas something like Hyperledger Fabric, it's designed to use existing Byzantine block-tolerance techniques. It should be capable of resisting attacks.
It should be, but
Or it is.
in practice, you're going to be dealing with entities you know, and you're not going to let any bozo just log into your blockchain.
Yeah, but what if some subset of them are been compromised, for example, or you have an insider attack with one of your organizations?
I mean, maybe we'll see a case where it is actually the right answer, but we really haven't seen one yet.
Yeah, I'm not saying I agree that's fine. There's a lot of hype, I agree, but I think it's a bit shallow just to say it's the same database. Technically,
I think it. Well, basically, I won't say philosophically that having all this do something good is impossible. I will say that I'll believe it when I see it, because the thing about the whole blockchain area is the hype to production system ratio is through the roof.
oh sure, yeah.
You get people promising things. We will totally have revolutionary magic beans and beanstalks in 6 months. You wait. We've got it all planned out, and it never quite works out that way. So
I guess my point is there is some technical innovation here. Whether it's actually useful in practice is
yes, this is an important thing actually. Bitcoin is really interesting. It's absolutely fascinating. Like that trick where you suddenly have a system where you don't have a central authority. It's a really clever trick, right? It's like, how did you even do that? But there's a real difference between interesting and feasible or useful. What you see with a lot of blockchain stuff is they'll have use cases that totally could never scale, for example. This is routine. And it's like no one ever ran the numbers and worked out they'd need a chain that grows a gigabyte an hour, that sort of thing. And the less people know about technology, the more amazing the claims are. And the worst thing is you see blockchain white papers where people who don't know the technology have repeated claims citing other papers from people who don't know technology and other people who don't know the technology, and you trace it back, and this is an interesting exercise if you're me, and it ends up at someone widely speculated perhaps we could do X one day, and slowly a could turns into an is. In blockchain publicity, you'll see is statements that are actually could or might statements, or we hope to at some point when we've invented a whole new area of computer science. And we'll invent the new mathematics in 10 minutes and it'll be a production system 5 minutes after that. And then we'll be there on time. But
Question, what the IBM's Hyperledger, what does it do on top of putting an SQLite database on Git? So I'm not trying to seriously, that strikes me as probably more efficient and would also give you the integrity assurances of if I have a local copy of my Git repository, then...
What does Hyperledger do that does more than an SQLite in Git? I actually saw a project...
What is Git? Sorry.
Git is a version control system. I would have thought everyone here would know what Git was. Okay. Git is a version control system. It's you put your code changes into it. It saves the entire history of your code base. It was invented by Linus Torvalds, the guy behind Linux. It's basically his second big hit. Most developers use it and they save their code in it. It's really good, and it uses a Merkle tree type structure all through. The threat model there was data integrity, like disk corruption and so on. You'd hash every change, you'd hash the complete tree, and if the numbers were fine, then everything was good. You can't remove items from a Git repository without it being immediately obvious and breaking everything. I've actually had to do this, like when people put binary blobs into a Git repo, and all the hashes change, and any automatic tools that work by hashes break, and it's all terrible, and you don't want to ever do that. So, but it uses that sort of structure, the sort of Merkle tree structure, a bit like this. So you have hashes at every step along the way, and if one bit changes, all the hashes change, and it's all wrong, which is a very useful thing to have. So Yeah, and developers routinely sling around entire Git repositories, like the entire blockchain of a given program. And you'll often hear blockchain advocates saying, well, Git was an early blockchain, but the only people who say that are advocates making excuses. So the answer to your question is no, I don't know. Someone here has questions, I'm sure. Yes?
In your presentation, you compared blockchain to a database lots of times, but that's not true. I mean, it shouldn't have been used as a database, right? So is it the case that people don't understand the technology and maybe the technology as well is not mature enough, and that's why this thing happened? Why it's a failure, let's say, at the moment?
Okay, so maybe it's just a new, untested technology. I would say maybe this is the case, but we've had 9 years of people hammering on this stuff as hard as they can, desperately trying to find use cases for it, find useful things to do with it. So far, they haven't come up with very much at all. I mean, when I say database, I don't mean plug-in substitute for MySQL. I mean just somewhere you put data in and get it back out again, which it totally is.
Yeah, but by design, that thing it's not designed to contain lots of data, right? It should be as
doesn't scale
as
at all.
possible, right? So if they store lots of data in it, then it breaks the whole idea.
Yeah.
But I'm not arguing that scalable, let's say, if you store less data, that problem does exist. But I think maybe there is no knowledge behind not enough technical knowledge, maybe.
A lot of the smart and misguided people are easy to find in the technology field. So a lot of smart people have turned their minds to trying to find a use for this system, and they really haven't come up with anything convincing.
Yeah.
Like the use cases I showed you are really the sort of thing people have come up with in practice. You'll have things like using it basically as a slow back-end database, or using it as running a sort of blockchain-like system, which is like a cryptocurrency with all the reason for the weird bits taken out but the weird bits kept, run by a central entity, and you go, yes, but why are you doing this? But as I said, just because the technology is completely inappropriate doesn't mean it won't be deployed in the wild. So I expect to see these systems around for years to come, and people like me will have to keep them working. What are your other questions? Anyone, please? Yes?
What about a next generation technology like Holloway?
Well, as I covered, that's with these sort of non-blockchain blockchains like IOTA. Holochain's another one. The Hashgraph, there's a pile of these, right? These are all attempts to do the Bitcoin trick without the bad bits of Bitcoin. So
they still are. They're not work. They haven't done it yet.
Exactly. They're attempts to do these things, but as I said, basically you should look at them when you have a thing to look at, because anyone can make promises, anyone can write some gibberish and typeset it in computer modern and put it up on the archive, and they do. So I would take it seriously when they have a product to show you and when they're not just selling you tokens. I must caution, sometimes the white papers are largely superfluous. I mean, some of these people are just really weird. I'm going to name one, IOTA, who are very special. They wrote a white paper about their fabulous system called the Tangle and how it will work. 2/3 of the white paper is superfluous because the whole thing runs off a central coordinator node, and they still haven't worked out how to get rid of the complete centralization yet. So the mathematics is actually completely untested because they don't know how to enable it. The organization is also very weird. They did things like the whole system runs in trinary because for some reason
Have they got trinary computers? I did see a little.
They were trying to sell. An early version of it was going to run on trinary hardware. So yeah, they also have some very strange and disconcerting behaviour. They do things like make legal threats against cryptography researchers who find bugs in their stuff, which is a 100% sign of a project that's absolutely nuts. This behaviour got them written up in the Financial Times, and UCL Blockchain cut off relations with them after that. So most projects are better than IOTA. I don't want to compare anyone to IOTA because IOTA are freaking nuts. Is the only way to put it. But I would say believe this stuff when you see it working and it does what they say in any manner as well. There was someone else?
What is the potential application of blockchain technology in future?
Sorry, what's that?
In future, the different aspect of application. I think the blockchain is a bit new technology that can be utilized to solve different problems.
So it might have potential in the future, but you could say that about anything. This is where you hit the problem that most new ideas are bad. Most new ideas don't work out. If you have a fabulously successful technology like the internet, you can go back through the old RFCs. You'll see a whole bunch of stuff that was never implemented because it turned out not to really work out very well. So you can say maybe about any technology, but when one has a track record like blockchain of lots and lots of promises and very little results, then even saying it could do well in the future is the sort of claim that really needs evidence. Like, a 9-year history of failure does not lead to an expectation that a 10th year of success. Usually it leads to a 10th year of failure. It might work out differently. As I said, I would love to be proven wrong.
I was just curious about, because I see you went through the applications of blockchain and everything, and what's your opinion on Ripple and the bank consortiums and trying to speed up the transactions through distributed ledger?
Okay, Ripple is a company that has a pile of products. They have their token, their cryptocurrency called Ripple, XRP, which is essentially centrally administered by Ripple Labs. There are 21, I think, nodes that calculate transactions by various processes of taking turns. Ripple Labs pick who gets to be a node and who isn't. Fundamentally, it's a centralized cryptocurrency. They have various other products that use various sort of ledgers and Merkle tree type stuff. They had so much of the XRP that they're a startup with a huge funding ramp. They could keep going for years trying to pivot to come up with a product they're good with. What you see in Ripple is mostly a lot of pilot projects, and one day they'll hit something they're good at, I guess. So they're not doing anything particularly radical. I mean, it's interesting in its way, but it's a centralized cryptocurrency, you know.
But have you seen any success stories within the banks? Because they are investing quite a bit, you know, with like R3 consortium and like a group of banks.
Yeah, people are trying this stuff really hard. There are things that claim to be blockchain descended or blockchain related or whatever. Often the relationship is there's a Merkle tree in it somewhere.
Okay.
You know, it's like some of it's often as blockchainy as KSI blockchain. Blockchain is a marketing term that means a particular set of promises, and it's probably got a Merkle tree in it.
You keep mentioning Merkle trees. Are there any other fundamental white paper type theoretical things that you think have promise that you
I have no idea if they have promise. I mean, as I said, the other attempts to do this trick with other data structures, Hashgraph and so on. No, I don't know of any. I am not a mathematician, so I look at these things and go, right, so I have to judge this based on their behaviour. If they're selling tokens, then probably their main interest is selling tokens. If they threaten to sue security researchers, they're probably insane charlatans or both. At a certain point, you don't have to look at the paper itself. You can look at the surrounding stuff. It's analogous to attacks on cryptographic systems. Bitcoin advocates will tell you we must use a country's worth of electricity to protect the security of the system. It is true that the cryptography in Bitcoin, trying to fake the blockchain, has never worked. It is actually a really strong system cryptographically, but nobody ever attacks a crypto system at its strongest point. They always attack the bits around the sides, and this is why Bitcoin exchanges get hacked roughly monthly, and people lose their coins a lot, and plain old fraud happens all the time, and it recreates the history of financial scams played back again, often with the same scammers. Quite a lot of Bitcoin scammers turn out to be serial fraudsters who had like mail fraud convictions and so on. It's a fascinating area in its way. Like, the dumb crook stories in cryptocurrency are amazing. Right, I think... Oh, we have... Was that someone at the back? One more?
Do they, like, secure multi-party computation strikes me as a much better, if you want to go to crypto and distribute trust, do any of them actually kind of consider the advances that we've made in the last 20 years in secure multi-party computation?
I've got no idea. The answer is, I would guess they would have, and then tried to sell some tokens on the back of it. Quite a lot of it is excuses to print your own magical internet money and get rich for free. Yeah. Like, you'll come up with the typical ICO white paper is 60 pages of implausible promises that will work because of decentralized, trustless magic, and about half a page of what actually happens with all the money and who gets it. So that half page is always the bit you should read.
What about non-financial things like verifying software and things like that? As a community.
I mean, you could use it for that, I suppose. I would see if it actually is the best and most workable method. I mean, the test would be something like, say, what does Debian do? Do they put all the hashes of all the packages on a blockchain? Turns out they don't. They distribute the trust in other ways. So you'd need to show a system that actually did this and that it was the best way and better than what we were doing now. And then it would arguably be a use case. There's all sorts of possibilities, and I will be delighted to see any of them in practice.
I think, putting Debian up as the gold standard of a well-run project must be that's a highlight, and we also are out of time, so let's think.
Debian is actually interesting because it's a whole bunch of people who don't necessarily get along with each other. They will fight like two angry computer geeks, but they somehow all have the same sort of project in mind, and somehow it all shuffles forth. Basically, the fundamental problem is you cannot solve social issues and human issues with a computer program. You can try to put it off a bit, but ultimately trying to automate trusting other people is something you do because you're not very good at the other stuff. It's like trying smart contracts is an attempt to end run around the law and how the legal system works from people who don't understand how it works. And it's one of those things where if you're good at something, that doesn't mean you're good at other things. I have expertise in a number of things. I'm a total dumbass in others, and I try to acknowledge when I am. I don't attempt to read, to understand white papers for complicated replacements for blockchain, but I can certainly watch their behaviour, that sort of thing, and try to make sense of things on that level, because most people aren't mathematicians. Is that it?
Yeah, we're also out of time, so yes. Thank you, David.
So you can email me there. There's my website, and I spend about 16 hours a day on Twitter. So I will be delighted to hear from anyone with further questions. Thank you.